Hello students, welcome to the lecture on multi-threading, I/O, and string handling. And after the lecture we will be able to learn the following objectives. Define multi-threaded programming, explain Java thread model, understand synchronization in Java, explain about input, output, and string handling, define streams and stream classes, explain character stream classes. Let's start with a brief introduction of multi-threading, I/O, and string handling. Multi-threading is a process of executing multiple threads simultaneously. Thread is basically a lightweight sub-process, a smallest unit of processing. Multiprocessing and multi-threading both are used to achieve multitasking. Java has a built-in support for multi-threading programming. A multi-threading is a specialized form of multitasking. Multitasking threads require less overhead than multitasking processes. A stream is a communication channel that a program has with the outside world. It is used to transfer data items in succession. An input-output I/O stream represents an input source or an output destination. A stream can represent many different kinds of sources and destinations, including disk files, devices, other programs, and memory arrays. Let's now take a look on multi-threaded programming. Java multi-threading allows multiple tasks at the same time. This is possible because modern-day computers have multiple CPUs. One CPU can work on one thread at a time. Unless CPUs have hyperthreading, it can handle two at a time. The implications of this are that one can take code and make it perform much better by introducing the use of multi-threading. That is, of course, if program would benefit from the use of multi-threading, some applications are fairly simple and things would just get overcomplicated by adding in thread logic. Let's know about the multi-threading. A multi-threaded program contains two or more parts that can run concurrently. Each part of such a program is called a thread, and each thread defines a separate path of execution. Thus, multi-threading is a specialized form of multitasking. In Java, the Java Virtual Machine, JVM, allows an application to have multiple threads of execution, running concurrently independently. The main purpose of multi-threading is to provide simultaneous execution of two or more parts of a program to utilize the CPU time. A multi-threaded program contains two or more parts that can run concurrently. Let's now take a look on the main thread. When a Java program starts up, one thread begins running immediately. This is usually called the main thread of program because it is the one that is executed when program begins. Although the main thread is created automatically when program is started, it can be controlled through a thread object. To do so, one must obtain a reference to it by calling the method currentThread, which is a public static member of thread. Its general form is as shown here. Let's now have a look at the Java thread model. Java environment has been built around the multi-threading model. In fact, all Java class libraries have been designed keeping multi-threading in mind. If a thread goes off to sleep for some time, the rest of the program does not get affected by this. At a point of time, a thread can be in any one of the following states: new, ready, running, inactive, and finished. A thread enters the new state as soon as it is created. A thread that is in running state can be stopped once its job has finished. A thread that is ready to run can also be stopped. A thread that is stopped enters the finished state. A thread that is in inactive state can either be resumed, in which case it enters the ready state again, or it can be stopped, in which case it enters the finished state. A thread has various stages during its thread model.
In today's tutorial, we're going to introduce you to something called a thread. Now, what a thread allows us to do is multiple things at the same time. So, if our computers couldn't use threads, then we couldn't be listening to music and surfing the web. Or we couldn't be using the microphone as I'm recording my screen right now. It'd just be crazy. So threads are pretty vital for everything, especially game development. I'm just going to show you a quick introduction to a thread, and then once we get into the game development section, I'll go into threads in more detail, or when we develop an application or something like that. But this is just a quick introduction to the thread. So here's our public void, or public static void method here, and I just created a new project. You don't have to, but just make sure you're in this method here because it's our main method. Now what we're going to do is we're going to create a thread, call it T. We're going to set this equal to a new thread, and just like we always do, something like that. But we're also going to give it some additional brackets instead of a semicolon like we usually do. Now what a thread is looking for when it starts is something called run. So what we're going to do is we're going to say, well, public void run, like that, and we're also going to give that some brackets there. And as you can see, before we get into our thread too much, it's giving us an error right here. This is the closing statement to this bracket here. All we have to do is put a semicolon here because again, it's basically the computer's reading this as one line of code, and we need to put our semicolon at the end. So now when this thread starts, it's going to call this run method. So whatever we want to do, we want to do within the run method. First thing we're going to do is just a system out print. Pretty basic, pretty familiar with this. We're going to get into some graphics here pretty soon, but I just wanted to show you guys the thread before we do that. And all we're going to do is we're going to say this is thread T, something like that, and bam, done with that line. And then the threads can also sleep, because they can work as hard as they want, but we can give them a break and just say, hey thread, sleep, and we give it a time such as 100 milliseconds. So that's 10 times a second. It's gonna be chilling, sipping on its water by the beach or something like that, and that's all it's gonna do. Now this is giving us an error right now because we have to surround it with a try and catch. Eclipse makes it very easy. We just hover over, say surround with a try and catch, and as you can see, we have a ton of brackets now. That's why we wanted to get that semicolon out of the way at the beginning. But there we go. Now our thread's going to sleep for 100 milliseconds. So it's going to run this system printout once, and then it's going to sleep for 100 milliseconds. So what we're going to do is we're going to enclose all of this code within a for loop. So we're just going to say for int I is equal to 0, semicolon, as long as I is less than, let's say, 10 for this example, and then I plus plus. And then all we're going to do is add some brackets here. And alright, and then what we're going to do to our for loop is just add a bracket, surround it, everything pretty much within our run method. So after we try and sleep, and it catches the exception if there is one, we're going to end it there. I'm going to hit Control-Shift-F to format everything, make it nice and pretty for you. So there we go. We have our thread set up. It's going to loop through 10 times. It's going to print out this is thread T, then sleep for 1/10 of a second, and then it's going to loop through our for loop again and print out this is thread T, until it does that 10 times. But the last thing we have to do is we have to start our thread. All we've done is defined our thread. So after this, where we placed our semicolon, we're going to go there, and all we're going to do is our thread name, which we called T. We're just going to say start. So that's going to start our thread, and bam, when we save this and run it.
Let's understand the thread opportunities. In Java, each thread has a priority. It helps the operating system determine the order in which threads are scheduled. Thread priority decides when to switch from one running thread to another. Process is called context switching. A thread can voluntarily release control, and the highest priority thread that is ready to run is given the CPU. A thread can be preempted by a higher priority thread, no matter what the lower priority thread is doing. Whenever a higher priority thread wants to run, it does. Let's know about synchronization in Java. Synchronization in Java is an important concept since Java is a multi-threaded language, where multiple threads run in parallel to complete program execution. Synchronization in Java is possible by using Java keywords, synchronized and volatile. Synchronized keyword in Java provides locking, which ensures mutual exclusive access of shared resource and prevent data race. Synchronized keyword also prevents reordering of code statement by compiler, which can cause subtle concurrent issue if one does not use synchronized or volatile keyword.
In this video, I'm going to talk about synchronized methods. Very important Java integration. What are synchronized methods in Java? Synchronized methods are methods that are used to control access to an object. A thread only executes a synchronized method after it has acquired the lock for the method's object or class. Synchronized statements are similar to synchronized methods. So the first step is, if you want to synchronize a method, you should use this keyword synchronized. It's a modifier, synchronized modifier you should use before the method. So I have a method public synchronized void thread safe method. So when you should use synchronized method, if your method is going to handle data that is shared between multiple threads. I want to repeat this again. If your method is going to handle the data that is shared between multiple threads, then you should have thread safe method. That means two or multiple threads should not access the same data and mess the data at the same time. So in order to avoid that, we want to protect this 10 lines of code. For example, this method has 10 lines of code. We want to execute this 10 lines of code atomic. That means single, make it single transaction. So first thread, if it enters, for example, first thread enters, it should complete the 10 lines of code, then it should release the lock. And until this thread 1 is complete, no thread will be allowed to enter any of this line of code. Okay, no other thread can enter and execute any line of this code. Okay, any line in this code. So for example, thread 1, it says I got the lock, so it will enter. Okay, the moment it enter, for example, thread 2 try to enter it, it will say I don't have the lock because thread 1 is already entered, no one can enter, and thread 2 will be waiting for the lock. So thread 1 entered, it does the atomic operation. That means 10 lines of code has been executed properly. Then once the thread 1 is done, thread 1 release the lock. It says I completed and I'm going to release the lock. That means any other thread can use the same lock and start executing the same code. So these 10 lines of code will become an atomic operation. Then thread 2 try to check whether lock is available. Yeah, the lock is available now because thread 1 completed all these 10 lines of code execution. It's done. So I'm going to use this. So it will enter, it will try to execute. The moment the thread 2 obtains the lock, nobody can enter it. Okay, enter this method because this is a thread safe method, because it is a synchronized method. So very important is, you can tell to the interviewer, if I want to make my method thread safe, I will mark that method as synchronized.
Here we will discuss about input, output, and string handling. In Java I/O, streams are typically byte-based. This means that one can either read bytes from or write bytes to a stream. Input stream. The class java.io.inputStream is the base class for all Java I/O input streams. If writing a component that needs to read input from a stream, try to make components depend on an input stream rather than any of its subclasses. Look at this simple example here to understand. Output stream. The class java.io.outputStream is the base class of all Java I/O output streams. To write a component that needs to write output to a stream, try to make sure that component depends on an output stream and not one of its subclasses. This example here shows how to push some data out to a file. String. Generally, string is a sequence of characters, but in Java, string is an object. String class is used to create string object. The string class is defined in the java.lang package, and hence its implicity available to all the programs in Java. The string class is declared as final, which means that it cannot be subclassed. The string objects are immutual. Example, once an object of the string class is created, the string it contains cannot be changed. In other words, once a string object is created, the characters that comprise the string cannot be changed. String comparison. The string class defines various methods that are used to compare strings or substrings within strings. Each of them is defined as equals method. The equals method is used to check whether the object that is passed as the argument to the method is equal to the string object that invokes the method. Value meaning. The invoking string is less than the argument string 0. The invoking string and the argument string are same. Greater than 0 and the invoking string is greater than the argument string. The string class also has the compare tollgnor case method that compares two strings without taking into consideration their case difference. The signature of the method is as shown here. Region matches method. The region matches method is used to check the equality of two string regions, where the two string regions belong to two different strings. The signature of the method is as shown. Starts with method. The starts with method is used to check whether the invoking string starts with the same sequence of characters as the substring passed as an argument to the method. The signature of the method is as shown. Ends with method. The ends with method is used to check whether the invoking string ends with the same sequence of characters as the substring passed as an argument to the method. The signature of the method is as shown here. Concat method. The concat method creates a new string after concatenating the argument string to the end of the invoking string. The signature of the method is as shown here. Trim method. The trim method creates a new copy of the string after removing any leading and trailing whitespace. The signature of the method is as shown.
Hi, welcome to my tutorial on inputting and outputting strings. What I'm going to do first is I'm going to make a label under .data, and I'm going to call it my word. And to reserve some space on this string or label, I'm going to type in .space, and I want to reserve about 20 characters of space. When I say 20 characters, each character is one ASCII letter. So in other words, this will reserve 20 letters or 20 characters. The next thing I'm going to do is I'm going to make it so that I'll be able to input a value inside my MIPS program. To do that, we have to use a syscall 8. So first I'm just gonna automatically do load v0, load immediate v0 8 and do a syscall. Now by this alone, it doesn't do anything. What you need to do is you need to let the program know where you want to save your string into. So I want to save my string inside my word. So what I'm going to do is I'm going to load the address of my word into the register A0. So what that is the address of my word into A0. The next thing I'm going to do is I'm going to make it so that I'll be only able to input 8 characters. So the way you do that is you do load immediate A1 and you type in 8. So whatever value is in A1 is the amount of characters that you're able to type in. Usually if you type in 8, it'll give you 1 less, so only 7 characters. It's usually 1 less than the number you put into A1. And finally we have load immediate v0 8 and the syscall, and then the load immediate v0 10, which ends our program. Now let's see how this runs. So I'm going to assemble it and I'm going to run, and here on the bottom you can see that in Mars that it gives you a place to type your characters. So I'm going to type in hello world, HELLOW. As you can see, the program finished on W. The reason for this is we only reserved 8 spaces or 8 characters, less than that is 7 characters inside A1. So if you want to be able to type in our whole entire hello world, I'm going to change this into 12 characters. Now let's see what happens. Run assemble, and I run my code, and HELLO space WRLD, and there you go. You can now type in your whole entire string hello world without it finishing by itself. Now if you noticed, I didn't press enter after I typed in D, and I didn't press enter after I typed in W, just to let you know. So now we have we have hello world saved inside my word. Now what I want to do is I want to print out my word and let's see what that gives. I'm going to give it 2 more spaces, a total 12, 13, 14 spaces, because I want to type in \n at the end of my string. So I'm going to load immediate v0 with 4 and do a syscall. What load immediate v04 does is outputs whatever value is inside A0, and in this case my word is inside A0, or the address of my word is inside A0. You need to remember that the actual your string, whatever you type in, is not inside A0. What is inside A0 is the address of my word. And we'll go.
Let's know about streams and stream classes. A stream represents a flow of data with, at least conceptually, a writer at one end and a reader at the other. When to work with java.io package to perform terminal input and output, reading or writing files, or communicating through sockets in Java, one uses various types of streams. Input stream, output stream. Abstract classes that define the basic functionality for reading or writing an unstructured sequence of bytes. All other byte streams in Java are built on top of the basic input stream and output stream. Reader, writer. Abstract classes that define the basic functionality for reading or writing a sequence of character data with support for Unicode. All other character streams in Java are built on top of reader and writer. Input stream reader, output stream writer. Classes that bridge byte and character streams by converting according to a specific character encoding scheme. Print stream, print writer. Specialized streams that simplify printing text. Let's understand about byte stream classes. Programs use byte streams to perform input and output of 8-bit bytes. All byte stream classes are descended from input stream and output stream. There are many byte stream classes. To demonstrate how byte streams work, one will focus on the file I/O byte streams, file input stream, and file output stream. Other kinds of byte streams are used in much the same way. They differ mainly in the way they are constructed. Let's now have a look on character stream classes. Reader and writer are the abstract superclasses for character streams in java.io. Reader provides the API and partial implementation for reader streams that read 16-bit characters, and writer provides the API and partial implementation for writer streams that write 16-bit characters. Subclasses of reader and writer implement specialized streams and are divided into 2 categories. Those that reads from or writes to data sinks, and those that perform some sort of processing. The class hierarchies for the reader and writer classes are as shown. Let's now take a look on the predefined streams. All Java programs automatically import the java.lang package. This package defines a class called system, which encapsulates several aspects of the runtime environment. System.in refers to standard input, which is the keyboard by default. System.err refers to the standard error system, which also is the console by default. System.in is an object of type input stream. System.out and System.er are objects of type print stream. These are byte streams, even though they typically are used to read and write characters from and to the console. Now in the end, let us summarize what we have learned in this lecture. Multithreading is a process of executing multiple threads simultaneously. A multithreading is a specialized form of multitasking. Multitasking threads require less overhead than multitasking processes. An input-output I/O stream represents an input source or an output destination. A stream can represent many kinds of sources and destinations, including disk files, devices, other programs, and memory arrays. A thread can be in any one of the following states: new, ready, running, inactive, and finished. The string class defines various methods that are used to compare strings or substrings within strings.